to myself.
Now we don't have to show up to class anymore. We can just watch the lecture online.
What do I got here?
An apple.
Not an apple, it's a piece of foam. It looks like an apple.
I wish apples were place.
What does it say on it?
Newton. 1 Newton.
It says 1 Newton. Why Newton? Who did we name that after?
Sir Isaac Newton.
We're getting started on Sir Isaac, who is sheer genius. If there ever has been a true genius to live, it was this crazy bird, Sir Isaac Newton. You gotta take notes too.
I know.
If you're really smart and genius and famous, you get a unit named after you. Because that's a unit, right? It's a unit of what? Force. For the next chapter, by the way, this is not on the test, this stuff. I'm just getting us a start. And mostly I just want you to think, you take some notes, I want you to think the way Newton thought. It created this whole mess. He really created this whole class. So force is the study of dynamics here. So up until now we've been doing what's called kinematics, which is just a description of motion. Dynamics explains it. And it explains it using this notion of a Newton, which is again a unit of force. So what about this apple is a Newton?
It's pull of gravity on it?
Yes, thank you. The pull of gravity on it, but more commonly, what do we call that?
I am on fire. You hear that?
The pull of gravity on you. We call that your weight.
Wait for it. Wait.
That's your weight. So weight is a what? It's a force exerted by whom? By whom?
Gravity.
No, gravity is the force. Who's exerting it?
The Earth.
What external body is by Earth? Okay. So let's throw it around. Ready? That's a Newton. That thing weighs a Newton. That thing weighs a Newton. Okay? Throw that around. I want everyone to feel a Newton. That's a Newton of force.
Oh my god.
What's this?
1 kilogram.
1,000 grams.
Otherwise known as a kilogram, right? What's a kilogram? What does it measure?
Mass.
Mass. What's mass? Is mass a force?
No.
No. It's not a force. What is it?
It's the amount of molecule.
It's hard to define without using it. Mass is the amount of mass, or mass is the amount of matter, by which you mean mass, right? So even though in chemistry mass is defined as the matter, stuff, the atoms, right? What is mass? And if you think about it very carefully, it's actually a very deep question. In fact, it's on the forefronts of modern physics. What is mass? What is that thing called mass? What has more mass, a flea or the Titanic?
The Titanic.
Why?
Because it's bigger.
There's more.
There's more stuff.
There's more stuff in the Titanic.
Which one of these is bigger?
The apple.
And the foam.
One of those is
apple.
bigger.
The foam apple.
This is bigger. This has more stuff in it, right?
Yeah.
But what is it about the stuff that gives it mass? It's kind of a weird question, right?
Density.
Well, no, density is just mass over volume. That's just a ratio.
The Higgs boson.
Isn't it inertia?
No, its mass results in it having weight, right? Right? Because if I go out in outer space away from any gravitational field, away from any planet, how much weight does it have?
None.
None. Does it still have mass? Yes.
Isn't it its inertia?
Thank you. You get an A for the day, yes.
Did you read it? Too bad it's just for the day. For two. Too bad for the year.
What's that though? That has kind of a different explanation than just amount of stuff, right?
Inertia.
Inertia matter an object needs to move, and when it is moving, it's unwillingness.
Yes, we're kind of personifying it there, but that's okay. Yeah, it's a measure of an object's willingness is a little generous, personality-rich kind of thing to say. But what is the, is it easier to budge the Titanic or a flea?
A flea.
A flea. So, because it has less inertia, which is less what? What is inertia? How would you define inertia? Willingness to, but willingness, let's use a different word.
Ability?
Tendency to move. You could.
How much
Force required
tendency to
to
move
move.
does the calculator have?
A lot.
None. How much tendency to move does any mass have? It has no tendencies. Right?
Ease of movement.
And actually that kind of touches on, because Leibniz had a very different view. Leibniz, who was a contemporary of Newton, had a very, by the way, the two of those created calculus. Sidebar. So, Newton. You're in college, sophomore year. Everyone gets sick, they call off class. What do you do?
Videotape yourself.
You go, they send you home. What do you do?
Sleep.
Sleep, have fun, play video games.
Develop a new branch of science. Homework.
Not quite, but if you're Isaac Newton, you develop differential calculus. This is what kind of person we're dealing with here, right? Your BC Calc, and then Leibniz also independently developed calculus. You probably learned about him in math class, right? That's why you have AP Calculus, those guys. So, where was I? Inertia. So, where was I?
Resistance.
Resistance to what? Well, let me put it this way.
Resistance to change.
Not resistance to force, resistance to change. Now this is the essence of the whole Newtonian way of thinking. Leibniz wanted to say that things had this innate kind of animation, these impulses, these tendencies to do this or that, right? Newton and Descartes said no, stuff is just stuff. And its natural tendency is to not change, right? To not change. That's what inertia is. Tendency to resist. It's actually a measure, it's a direct measure of resistance to change. Specifically, when we're talking physics, right, physical inertia, resistance to change in what?
Position.
Close.
Speed. Velocity.
Yeah, motion or velocity. Or motion or rest. Motion is the same thing. Resistance to change in motion or rest. So, if you're sitting there on the couch with your potato chips and your Bud Light and the Chiefs game on, your natural tendency is to keep eating potato chips, drinking your beer, and watching the Chiefs game, right? That's inertia, right? That's psychological inertia. Or institutional inertia is resistance to change in general. Yes?
Doesn't that somewhat contradict the theory of entropy?
Well, I was going to bring up a different example. Yes, that's one. The other big one that it's in kind of in contradiction to is evolution. What's the whole name of the game of evolution? The natural tendency of living systems is to change. No. You walk into the room. This thing is sitting here. Its natural tendency is to keep sitting there. It's actually more in line with entropy. Right? Just keep sitting there. If you walk into the room, all of a sudden you see this go. That is not natural. We know what? Rest is natural.
Activity 4.
It's natural to keep being at rest unless what?
Something happens.
And that thing is called a force. Right. So Newton's laws. You already know these, I'm sure. But we need to know them intimately and deeply. Newton's laws. Number one, the law of inertia. Go ahead and stop the video for a second because we need to chop it into 15-minute pieces, or if it's over 15 we can't put it on YouTube.
Okay.